We're going to divide this down the middle and factor it. Because if you take it in like small chunks, things are a lot easier. All right, so I know you were gone yesterday, Miss W, so pay attention to this really close. These both have an x squared in them, so I can take that out. You just work on factoring the first two terms, okay? And then you should have x minus 5. How about the other two? What do they both have in them? A 6. So let's take out that 6. And then what's left if we take out the 6? X minus 5. Coincidence? I think not. So those two get factored out also, because that and that are a common factor again. Just like a 5 or a 6 was a common factor in both of these, then an x minus 5 is a common factor in both of these terms. So the x minus 5 comes out to the front, and then when I take it out, what I'm really doing is dividing by x minus 5 on the top and the bottom, and those cancel, leaving me x squared plus 6. But I encouraged you to factor it all the way, because it helps you find these imaginary roots. Remember how you're going to have to find these anyways? So you factor it all the way. What do you mean, Mr. Server? Isn't it factored all the way? Nope. That can factor into x, and plus and minus, and square root of 6 and square root of 6. But that wouldn't quite work. Maddie, what's wrong? Why wouldn't this plus and this minus work to give me that? It'll give me a negative 6. So how do you fix that? Put an I in front of both. And then I got my answers. Regular 5 makes this part 0. Remember, the whole point is to make this equal 0. It says that right at the very beginning of the problem, equals 0. And so a positive 5 would work. X equals 5. And a positive and a negative. Oh wait, I'm putting it on the wrong blank. I'm going to put this in imaginaries. A positive and a negative I root 6 would be the imaginary roots. Now those are not x-intercepts. You know why? Because you can't see them on the graph. So what would this look like on a graph? I know it would go through 5, because that's a normal number. It's a real number. I also know that the lead coefficient is positive. The lead coefficient is x to the third, and it's a 1 in front of that. That's the lead term, sorry. So the lead coefficient is a 1, and that means it's positive, so it's going up on the right. I could also figure out its y-intercept is negative 30, because it says so right there. The y-intercept is where x equals 0, right? So then it goes through here, it goes through negative 30, so I'm going to make it go down a little further. And what it does the rest of the time, I'm not sure, except that it is odd, so the ends have to be going opposite directions. So this end has to be going down while this end goes up. It has to go through that spot, and it has to go through negative 30. And that's the big picture. So what else do you need to know? What else could you know? Well, there's a way to factor things with 5 terms. What we just did there, that's factoring it if it has 4 terms. There's a way to do it if there's 5 terms. And that last way is what I'm teaching you today, and that is called long division of polynomials. All right, so I'm going to make sure that you remember how these work with regular numbers first, because some of you, I know, right this second you're like, oh, I don't even know how to long divide. How am I supposed to long divide polynomials? I'll remind you how to long divide. And I often think kids don't realize this. You're way smarter than you were the first time somebody tried to teach you to long divide. So some people are like, I never got that. Well, you weren't that smart back then. Some kids were smart enough to get it right away, and they got it, and you maybe weren't. But now you're way smarter than you were when you were in 4th grade or 3rd grade, and they taught you how to long divide. So I can teach you now, and if you never got it before, let me show you how. All right. So if you're going to get this one with long division, you first have to understand how to regular long divide. Okay, so let's look at this slide. purple one. It says, is 7 a factor of 83? I'm going to do long division. And you see if you remember. You know what? I'm just going to see who in here can do it without a calculator. Go ahead and long divide 7 into 83. I'm not going to set it up or anything. I just want to see how many of you can pull it off. Already have it in your wheelhouse. My gut says 60% of you will be able to do this properly. And if you're not one of that 60%, it's all right. I'll teach you. And pause for a second. Let me give that a try. All right, so here's how you do it. First of all, the 83 goes in the little house. I call it a den. Why? Because this is called the dividend. And then the other number is kind of the dividing number. It's the divider, but it's actually called the divisor. You do need to know those words, dividend and divisor. Dividend is in the den. All right, next, you're going to go, does 7 go into 8? Notice I'm just looking at the first digit here because this is a one-digit number. I'm going to look at that 8. Does 7 go into 8? Yeah, of course it does. One time. And then watch what I do with this. I take 7 times the 1 and I put it here. I draw a line and then I'm going to call this, make it the opposite of 7. I know some of you are like, it's just minus. But the reason I say make it the opposite of 7 is that in our work today, you're going to sometimes have a negative number that you have to make positive. So you make it the opposite of whatever it is. Okay, then I combine the 7 and the 8, which I know that means subtract in this case. But again, on our work today, if those were both positive numbers, we put them together. All right, so we put these two together, and I get 1. And now, I can't just keep doing that. Does 7 go into 1? Of course it doesn't. I just took out all the 7s. So the next thing I do is bring down the 3. And now, does 7 go into 13? Yes. How many times does 7 go into 13? Once. 1 times 7 is 7 again. Make it the opposite. Draw a line. And I subtract them, and I got 6. Now, a lot of people right there are kind of stumped. They don't know if they should bring down something else that isn't even there. They don't know what the 6 is. And they don't know how to finish. Okay. Well, there's two choices. You can either say, is 7 a factor of 83? And the answer is no, because it has a remainder. Did you remember that word? Of 6. Another way you could say it is that 7 times 11 plus 6 will make 83. I don't know if you ever knew that before. You just add the remainder and you'll get your 83. But it's off by 6. Okay? And the last thing you can do is you can make it a fraction. Who knows what I'm talking about? All right. Gavin, I'm curious what you think I mean.
You bring down 7.
Okay, so what do you think the answer is?
11 and 6/7.
You are correct, sir. 11 and 6/7. Now, I know some of you are thinking about making this a decimal, and that's okay. If you wanted to make it a decimal, you would have added in a decimal point and a 0 and brought down a 0, but the thing is, 6/7 is not a nice decimal. It would go on for a long time. So this is done and correct, 11 and 6/7. But the question was it a factor? No, because 7 didn't go into 83. What's the closest thing? Well, 7 times 11, which was 77. That was the, well, actually, something even closer would have been 7 times 12. And that would have been 84. So it was really close to going in, but it didn't go in. All right. You're going to have to do that same exact thing, except with polynomials. So we got to get good at this with numbers first. So I want you to try one more here. I just helped you with a reminder of how it works, and I will help you again. The dividend goes in the den. The divisor goes outside. It's like the divider. And now you say, does 18 go into 28? Yeah, it's just a question of how many times. It's in there once. It'll be 18. Make it the opposite. Subtract them and you get 10. Does 18 go into 10? No. So then you got to bring something else down. Now it's 108. Does 18 go into 108? I know that's a bit of a pain. Think of it as like 20 going into 100. I go in there about 5 times, and I know I'm close. So here's what you do. You think, okay, I think 5 is going to work. Put a 5 up here, and then you multiply it out. 5 times 18. Well, you don't have to do it all at once. You could do 5 times the 8, and that makes 40. But you got to carry the 4 up here. And 5 times 10 is 50, plus the 4 is 90. And how far was I off? Ooh, wait a minute. Oh, there's 18 left. Do you get that I could have gone in one more time? So it probably should have been a 6. So I'll double check that, but we'll make that a 6. And then 6 times 8 is 48. And 6 times the 10 is 60. Plus another 4 is 64. What the heck just happened there?
It would just be 6 plus 40, so 60 plus 40. Which would be
You're right. You're right. Thank you. 6 times the 10 plus the, it's really 6 times the 1 is 6 plus 4 more makes a 10. Whew, my brain just shut down for a second there. That was weird. I can do this. I really can. Okay, anyway. There. So now I got a 0 remainder. What does that mean? That means 18 is a factor of 288. Because it goes in exactly 16 times. If you wanted to say it's a remainder, it'd be remainder 0. If you wanted to say that fraction thing, it'd be 0/18. 16 and 0/18. Okay. Let's see if they think we're ready to, yep, they do think we're ready, and I think we are too, to try a real one. X squared plus 2x minus 3 is the dividend. Goes in the den. And the x minus 1 goes on the outside. Now, hint for you. Always start with an x up here. And then just see if it works. Sometimes it will. And if it doesn't, you'll be able to go, how far off was I? And then I maybe, oh, well, maybe I need a 2x, or maybe I need an x squared up there. This number gets times by this, but you can't just times it by the front number. You have to times it by both of them. So x times the x is x squared. X times the negative 1 is negative x. You draw a line. It'd be very tempting right here to just combine them right now. But you don't. You do the opposite, opposite. Remember me saying before that we would just change the signs? We weren't just going to subtract? Because there, this one is a great example. One of them becomes negative, but the other becomes positive. Then these two cancel. This is 3x. Bring down the minus 3. If this has 2 terms, you're always going to want 2 terms down here to go with it. And then, I hope your gut is to put a 3 up here. 3 times the x, 3x. 3 times the negative 1 is negative 3. Draw the line. I always do opposite, opposite. Opposite, opposite. And then these cancel, and those cancel. And I have 0 remainder. Yay, it worked. But my dad always said, you weren't done until you put the tools away. Okay, so we aren't done with this until we actually write out the answer, which is x minus 1 times x plus 3, and answer their question. Is that a factor of that? Yes. How do you know? Because look, I factored it. And that's all this really did, is it factored it. That's what polynomial long division does, is it factors things. Now, some of you guys are going to later learn another method that's faster than this, that's like this, and it's called synthetic. But I'm warning you, when you get to pre-calc and when you go to the ACT test, they can ask you to do polynomial long division. This, what we just did right here. It's in next year's class, and it's on the ACT, and synthetic isn't in either one. Okay, so the synthetic that I'm going to teach you is a nice shortcut to this, but this is really important. Like, the more I learn about it, the more I realize, dang, this is in a lot of important places, like higher level classes and on the ACT. All right, so let's take one more to make sure there isn't some tricky stuff that's holding you up. Dividend goes in the den. Divisor goes outside. Now I'm just going to be quiet while you give this a try. See if you can do it. Is it possible that the answer will have a remainder? Yeah, and then the answer is no, it's not a factor. That's what you're trying to do, is figure out if this is a factor. And sometimes they work out, and sometimes they don't. Okay, for anybody who's kind of stumped on even how to start. First step, what did I say to always start with? An x. If I put an x up here, it will not work because it says x squared right here. Does that match up with the first term? No. Who figured out that I needed to put a 3x squared? Raise your hand if you figured that out. Okay, awesome. Then I will end up with 3x to the third, just like I wanted, and it'll cancel out the first term. That also gives me 3x squared times 2, which is 6x squared. Draw the line, do opposite, opposite. I'm going to use a different color just to make it stand out. Those will cancel. And I have 7x squared, and I need, since this is a binomial, I need to bring down another term, plus 10x. And then from what you just did last time, I hope you know we start with an x. Quickly realize x times x would be x squared. It's kind of close, so I needed a 7x. 7x times x is 7x squared. 7x times the 2 is 14x. Really easy to forget the negative negative, and I bet all of you will at some point, because that would totally change what we'd have next. This is negative 4x. Oh, that it's very hard to see, so I'm going to change to red. Bring down the minus 1. What needs to go here? Negative 4, I think, so I'm going to check. Negative 4 times x, negative 4x. Negative 4 times the 2, negative 8. Dang. Opposite, opposite. Why did I say dang? Because I did not everything all canceled out. I ended up with a 7. Now there's two choices here. I either screwed up something, or I did it right, and this is not a factor. All right. I have one backup way to check if this is a factor or not. If this is a factor, then do you get negative 2 would be a 0? If negative 2 is a 0, that means if I put a negative 2 in all these spots, it should equal 0. That's a pretty slick way to do it. You just stick in negative 2, and if it equals 0, then this thing was a 0, and I screwed up in my factoring. So this is just a way to double check yourself. I'm going to make sure by going like this. Okay, let me think. Negative 2 to the third is negative 8 times 3 is negative 24. Negative 2 squared is 4. 4 times 13 is 40. 4 times 3 is 12. 52. This is negative 20. This is a negative 1. does that all add up to 0? No, it does not. It adds up to 7. It's not equal to 0. So the negative 2 was not a 0, which means x plus 2 was not a factor. So the answer to the question, no. And you know what proof we want? The remainder. Do you get how it might be a kid just gets stuck on a problem? Because they screwed up the math on it and it's not working and they think, oh, it's not a factor. So they write no. But if they have no and the wrong remainder, it means they did it wrong. You can't just say no. You got to say no because there's a remainder of 7. How many of you actually got a remainder of 7 without like biasing from me? Okay. Did anybody think it actually worked? Okay. All right. Let's go to the next. This time, I'm not even setting it up. See if you can take it from here. Is that a factor of that? And if so, tell me what it factors to. All right. Pause for a second while you give that a try. Okay, let's see how you did. What's the name of the thing that goes in the den? Dividend. This thing that goes on the outside, anybody remember it? Divisor, very good. And what do I always start with, Rehan? Yep. Is x actually the right call in this case? No, but it's easy to tweak. I can make it x squared. And x squared times the x makes x to the third. X squared times the negative 5 makes negative 5x squared. And that's cool. They both drop out. Wait, first we have to change signs. Opposite, opposite. Yeah, they both drop out. And then that means I got to bring down 2 things. Because remember, if this is a binomial, then I need a binomial to work with. So then it's plus 2. And then the 2 comes down. 2 times x, 2x. 2 times negative 5, negative 10. Opposite, opposite. 0 remainder. Sweet. Remember to finish the deal. Clean it up. X minus 5, x squared plus 2. And for extra bonus points, did anybody think to do this? X plus x minus, and do you remember how to do this again? I root 2. I root 2. Why is that smart? Because that'll remind you what the 2 imaginary roots are, and it reminds you, because there's i's in them, that they're imaginary. Otherwise, I oftentimes I'll get people that think the answers are either 2 and negative 2, or they'll think it's the square root of 2 and the negative square root of 2, and they forget the I. So anyway, if you can get it factored to like this, that is the state of the art. That's the best. It's factoring over the complex number system, and most teachers aren't even talking about that, but I found a few kids were doing that, and they were always getting them right. Like there was a strong correlation with the kids that would factor it all the way like that, got the answers right on the test, and the other kids weren't. So I'm like, maybe I should just tell everybody to do that. Do you have to? Nope. Could have left it here. But then when you're asked what the roots are, you're more likely to mess it up. So. Okay. Is this a solution to that? That feels different. But it's really a lot the same. Let me show you. I just told you a second ago that if it's a solution, that means it's a 0, right? There's 4 names for them. It also means an x-intercept. It also means other things. But all I really care about is if it's a solution to this, then do I need to go through all the work of long dividing? No. If they want to know if it's a solution, don't answer that question. Tell them whether it's a 0. Because 0 and solution are the same thing. So does it make it equal 0? So I stick a 2 in here. And if that equals 0, then it was a solution. And it's a 0. You got to do some math. 2 to the fourth, 16 times 2 is 32. 2 to the third is 8 times negative 3 is negative 24. 2 squared is 4 times negative 5 is negative 20. And then plus 6, and then plus 6. All right, I want to put some of these together. This is a negative, this is a negative. So that's 32 and minus 44. And then this is a 12 and a 32. Makes a 44 minus 44. Oh my gosh, it does equal 0. Guess what would have happened if I would have long divided it? It would have had no remainder. It would have worked. But since the question was, is it a solution? Your answer is just yes. What's your proof? You showed that it equals 0. So there are times you can get out of long dividing. Now another kid might have actually done this way. They might have long divided. And would I have said that the answer was wrong? Nope. I would have just said, man, there was an easier way to do that. But you could long divide this thing. I'm going to do it at light speed. 2x to the fourth minus 3x to the third minus 5x squared plus 3x plus 6. And I would not say a 2 out here. I'd say an x minus 2. Okay, then I'm going to put up a x to the, it'd be have to be a 2x to the third, and that will make 2x to the fourth. And then I multiply it down by the negative 2, and I make negative 4x to the third. Draw a line, opposite, opposite. Those make x to the third minus 5x squared. So, man, this is going to be a lot more work. Is it worth it? Only thing that's good about it is it's factoring this. So if the follow-up question on the test was, factor this, then the smarter way would have been to do long division, because that's what it's doing, is it's factoring. All right, so then I'm going to say plus x squared times x makes x to the third, x squared times the negative 2, negative 2x squared, opposite, opposite. That makes negative 3x squared. Bring down the plus 3x, and then I need a negative 3x here. Negative 3x times the x makes negative 3x squared. Negative 3 is a positive 6x. Draw the line, opposite, opposite. That's negative 3x plus 6. So last thing I got to put up here is a negative 3 times the x makes negative 3x. Negative 3 times the negative 2 is positive 6. And look at that, they're exact opposites of each other. I get 0 remainder. Yay. That's the long way. Only thing that's good about it, it's been factored. Remember me saying you're not done until you put away the tools and get down to just the answer? Yay. And after all that work, if the question had been factor this, the kid would get it wrong, because it isn't factored all the way. Are you serious? Yes. That's factored all the way, but that could possibly be factored again. The first thing I would look for is divide and conquer. Turns out it actually doesn't divide and conquer, so that's not it. Is there another way to factor it? Only if they tell you another root. Like if they said, oh, by the way, 3 was also a solution to this. Like they said, x is 2 is a solution. If they gave me another root, then I could long divide this again. My point, always look and see if you can factor it further. Because kids usually get done with a problem like that, and they're like so many steps, and they think, oh, finally I'm done, and it's not actually done. Look, see if it could be factored again. All right. Yay. I don't think we need to keep doing these ad nauseum, but this one does have a missing term, and I need you to see one like that. So everybody set this one up with me. The dividend goes in the den. But wait, after 9x squared, what's weird? Do you notice there's an x to the third, an x to the second, there's no x to the first. So the smart thing to do is plus 0x to the first plus 15. Did I have to do that? Nope. Will it make your life a lot easier if you notice it? Yup. It's one of these things where things wouldn't line up nicely unless you have that 0x in there. Okay, so that's pretty much it. Other than that, it's just going to be like the others. You just needed to have that underlined 0x in there. So see if you've really got it. This will work if you do it right. I'm going to pause for a second while everybody tries one last long division. And that's all I have for the video for today.